Good evening, Hacksters. Today we are putting together the second one of our Circuit Classics kits from Star Simpson. So previously we put together this one that was this one here, the stepped tone generator, and today we're going to be assembling the Bargraph voltage indicator. So a note from last time, this goes into the previous video goes into all the details about Circuit Classics, and you can find out more about them on circuitclassics.com, which is also pulled up right here. But I want to note that the last time we did this, there was a capacitor that was not the right one that was included in the kit, and it turns out that that was a one-time deal that came out of the crowdfunding effort. The very first round of backers received one with a wrong capacitor, but it turns out that A, you can replace it with a non-polar film capacitor, and B, later versions all got the correct capacitors. So I don't want that to reflect poorly on the kits at all or whatever. So we have here, I've actually put in here the previous one with a film capacitor subbed in for one of the polar capacitors that was there before, and it makes some pretty cool noises now. So it does little beeps and boops and stuff. It's a little quiet, but yeah, maybe if you put an amplifier on there or something, it'd be super rad. So I'm going to make that stop clicking now. That is the stepped tone generator, which we did last time. These are all circuits designed by Forrest Mims, who created the Engineer's Mini Notebooks, and they have some cool features, including, for example, this sort of textured surface here, which is created by having a layer of copper under the solder mask. And what that does is it emulates the lines in the notebooks that Forrest Mims included, so you can kind of see the texture there, which is super cool. And all of them have that. It has the circuit itself with, of course, the components labeled where you're going to solder them in. And then here you have the circuit schematic, and then on the back you have the other half of the schematic diagrams. But what's really cool about this is that it shows you all the traces on both sides of the board. The ones shown in white are where there's a trace on this side of the board, and the ones shown by removing solder mask in that area are the ones that are on the other side of the board. So that's super cool. Another thing that I didn't realize at the time is that this wooden block I thought was just a stand to show it off and look pretty. Turns out that that is actually because also not everyone has a third hand and things like that. And it turns out this is actually really handy for being able to hold the board stably while you're soldering on it, even if you don't have a third hand. And so that way it's really easy to get started. And this comes with the kit itself. So putting that one aside, we're going to do another one. And today we have the Bargraph voltage indicator, and by Bargraph I mean Bargraph. We are not hunting wild pigs. We are. So that'd be pretty cool. Imagine if you had a bunch of boars and you needed to know their voltage for some reason. I don't know. You can't use the wrong voltage of boar. It would be disastrous, obviously. So here we have another one of these cool little wooden stands, which you can use for display or as a sort of soldering stand. We have a little cartoon. It tells us about the kit itself, which we'll look at in a second. A nice postcard view of the kit itself. We have our components and how to solder from Getting Started in Electronics, page 98 by Forrest Mims. Very cool. Message to the backers. And of course, the star of the show, wrapped in tissue paper, this beautiful blue circuit board. At the time these came out, I hadn't seen a ton of different colored circuit boards on the market in the hobbyist area. And it's very beautiful. So again, we have our schematic, Forrest Mims signature with the solder mask stripped away in that area, and or never applied really, and some copper. Then we have the actual circuit with its labels, and all the white lines here have copper underneath them. That's where the traces are on this side of the board. And where there's no solder mask, that's where the traces are on the other side of the board, and those are shown as well. LEDs glow in sequence as input voltage rises. R1 controls sensitivity. Adjust R1, which would be a variable resistor, to achieve sensitivity up to a few millivolts per LED. Whoa! So you can get really tight resolution with this, apparently. And I chose not to assemble this one last time because I didn't know if it came with something that would output variable voltages. And I was like, well, I'll have to go find something. And, I really want to get something to put together. Turns out that this kit includes something that you can measure, apparently. So we'll have a look. Yeah, the blue color is just gorgeous. We'll get that shine off of there. So what do we got in here? Woo! Bunch of stuff. Let's get you out of the way. I see some resistors, an LED, a chip. More resistors. Here is our variable resistor. More resistors. We've got a couple of alligator clips again. This time we have 3 of them. And yeah, our little feet, which actually might be for this wooden stand. Last time I assumed they were for the circuit board, but yeah. And then, battery connector. Excellent. Okay, so we're going to group these things. LEDs over here. You guys can hang out and wait until the end. Tariq says, how much are those? Let's find out. You can get them on Crowd Supply now for $40. Cool. Back to our desktop here. We have this cartoon that says, Bargraph voltage indicator. Let's say you have a pitcher of lemonade and you want to know how much lemonade is inside. And because of a totally innocent misunderstanding, you may have superglued a lid on top so you can't just look inside. My first idea was to drill a set of holes in the pitcher, and I would know that the lemonade is somewhere above the last hole leaking lemonade. That works, but that kind of makes a mess, and it wastes valuable lemonade. So by measuring it, you're getting rid of all the lemonade in the pitcher. That's no good. Then I had a great idea. I could put balloons over the holes to keep the lemonade from leaking. If the balloon fills up, there's lemonade above that level. So you got a little floppy balloon on the top where there's no more lemonade filling it. The circuit works the same way. It has 4 parts called comparators, which electrically test if the voltage is higher or lower than a reference level, just like checking if lemonade leaks out of a hole. That's super cool. If the voltage is higher than the level, the comparator turns on an LED, like the balloon filling up with lemonade. I've never actually worked with these before. That's super cool. Circuits by Forrest and Mims III. Board design and concept by Star Simpson. Illustration by Paulin Albino. Words by Alex Hornstein. Good team. So let's start putting this together. I'm going to start, as per usual, with the lowest profile component, which in this case is the resistors, also as usual. And then I will put on, let's see, probably the chip and the battery connector, then the LEDs, and then the... actually, I put the chip on last. It really, typically I'll go from like lowest to highest because that makes it easiest to like keep soldering. If you have to solder around tall components, that's no fun. But also chips are sensitive to temperature, and so you want to sort of make a call on that. So I'll usually do chips last, even if there's other stuff that's taller. So we'll put those in order over there. Do-do-do. Do-do-do. Do-do. Do-do. Speaking of Doot, actually, a friend just created a Doot button that you can get on OshPark. I'll find that and link it in the description because it came out of when we were talking about the SparkFun micromod kits, and I saw they had a little button on them that was marked Doot, but it turned out to be Boot. But now Doot buttons are becoming a thing, which makes me very happy. Are these all the same value? Oh, we got 100K, 1K, 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 1K. All right, cool. So 9 resistors that I can see. Oh wait, their variable resistor is 100k. So probably like 8 of the same normal resistors, and then one, this guy is probably 100k. This guy. And then we've got all these gates, logic gates, which I believe are just part of the chip here. And then we have our LEDs. Beautiful. And you can input variable amounts of voltage, +3 to +9 volts. So let's, yeah, these guys are all the same. Great. Just start sticking those in. Wait a minute. Which way does it go? R1, R2, R3, R4, R5. Huh. Oh, okay. That's the variable resistor. And then R2 goes here. I keep forgetting that that's labeled R as well. I'm going to try and bend the legs here a little creatively so they don't overlap with each other too much. But we'll get those bent and inserted. That just holds them in place before I solder all of them on. So I can put all of them into the board and then solder later. Ooh, okay, good. I thought I'd lost a resistor, but it just tried to scram across the table. No! I see you. I see you, resistor. You will not get away. I don't see why they would want to get away anyway. If it gets away, it's just going to sit in my drawer for ages. Someone's going to be mad at me for not putting all the stripes in the same direction. These are non-polar. It doesn't matter which way you put them in, but there's always someone who is going to be in the mentions being like, hey, you should align all the stripes. Now, will it be worse now if I align all the stripes on the right here? Or would it be better for the artistic effect to have them be more random? The problem is that now I'm thinking about it, so they can't really be random. But also, I have a natural advantage here, which is that when I'm not wearing my glasses, it's a lot harder to tell what the stripes are from this far away. So, we're gonna get the same effect anyway. I can't even pay attention to that. Doot, 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 doot. Also on the subject of doot, slowly and surely working towards making some beep boops on Sonic Pi that I can use as background in videos. Did some generative music a while ago using data from satellites with my friend Mohib and our team for the Planet hack a while ago. And I used Sonic Pi to create music from the cloud cover data that Mohib retrieved from planet photos. Put up a blog post about that one, but didn't yet have it running on an actual Raspberry Pi, which soon I will. Actually, I've gotten a simplified version running on the Pi 400, which you see over there. Whoop. But I have more nefarious plans for that, so I'm not really publicizing it just yet. But if you want to share with me your favorite ways of creating generative music, especially beep boops, in the comments, then I'd be happy to check those out. By beep boops, I obviously mean like electronic music. Could be chiptunes, could not. Lo-fi, good stuff like that. I've been listening to a lot of that lately. There's some really good lo-fi remixes of like Star Wars music and stuff from Avatar: The Last Airbender, the cartoon show. Don't get mad at me about the movie. We all know about the movie. Now you're just gonna say, what movie? I know my audience. Okay, let's see. Stop being bridged. Stop it. This connection right here. These two resistors decided to conjoin themselves, but I won't be having it. just gonna... Well, I'll deal with that later. Ah! Yes, this is true. Mims is a legend. Star actually worked with him on this series of kits, which is pretty badass. I'm giving it a shot using this wooden stand, and I actually kind of really like it. I'm gonna blame any blobs that I get on the fact that I'm using lead-free, and I'm still not super great with it. Okay, here we go. Let's clip these off and deal with that one that's really stubborn over there. Ah! Did that one get enough solder? Yes. I like to hold it down with my thumb while I clip it off, because that keeps the leads from flying everywhere. And as I'm a bad person and don't wear goggles while I'm soldering, it helps protect my delicate little eyes. But if you're soldering with kids, or you really care about your eye health, you really should be using goggles, safety goggles, when you're putting stuff together, especially while clipping off delicate parts. You just like never know what might happen. I've found that lead-free solder especially actually tends to sort of sputter and spit and get everywhere. So it's a little more harrowing to work with. Okay, time to deal with this guy. I'm going to grab it and apply some tension while I melt the solder holding it onto this board. Get some solder on my iron. Come on, there we go. I clipped it off as well. That's because I'm not using pliers, but I'm instead using my side cutters, which is not the best tool for the job here, but whatever. There we go. Now some cleanup. Alright, that's not too bad. No, I bridged it again. Stop! I'm just trying to make sure that they're far enough away from each other. Doing a little cleanup. Just gonna make sure that these all look nice and pretty and are all sort of sucked in and adhered to their own pads. There we go. Alright, cool. Alright. Cool. So, now the battery connector, I think that is going to be a little bit of a pain as usual, because it's basically a big heat sink. It's a big piece of metal. The whole thing's going to heat up and just suck all the heat out of my soldering iron and the solder and the pads and whatever. So you just have to be patient with it. And what I'm going to do is apply a little bit to the middle pad here, even though that's where the ground side of the battery goes. There's nothing that's going to be soldered there. But I put a little bit of solder just to give it a physical raised profile so that it makes good contact with the battery. Beautiful. Okay. And I am definitely going to break out some pliers to hold this in place because this thing will suck the heat, as I said, out of the soldering iron and into my fingers if I tried to hold this by hand. I love this Leatherman squirt. It's so good. I've had it for like 5 years now from one of our hackathons. Just gonna heat this whole assembly up here. And eventually, it's all gone solid. Come on. Get some more thermal transfer in there. Larger surface area. Aha! There we go. Beautiful. Let that cool for a second. Alright, now the other side. This is a little bit crooked, but it's fine. No harm done. Okay, good thermal contact. Oh, that's going much more easily. Just wait for the whole blob to melt, including the stuff underneath. There we go. Beautiful. As long as it's on pretty straight, it's not going to cause any shorts with the battery or whatever. There we go. Okay, time for LEDs. I wonder what colors they are. I haven't really looked at the website for this one. We will, you can check out down below this video in the description. There's links to the page for this kit as well as the video for the previous kit assembly. So if you're curious, you can skip ahead and take a peek, but I'm not gonna. So we have an LED here, and it is a single color LED unless it has a little, sometimes I have a little circuit in here that will change colors or flash or whatever. We'll find out. And you can tell the polarity of the LED in 2 different ways that I know of. I mean, unless you like memorize what the inside looks like, which I always forget which way it goes. You have your short leg for ground and your long leg for positive, but also there's a little flat side on this LED. It's like it's sanded down, but it's really just sort of molded that way probably. If you can see, there's a flat side here that also corresponds to the short leg or the negative side. And I like to think that that flat side looks like a minus sign. So that, even if you've already cut the legs off of your LED or soldered it in somewhere, you can troubleshoot or tell the proper polarity by seeing which side that flat side is on. Do the same thing as with the resistors. We poke it through and then bend the legs out. Plus, when you've bent the legs out, you know, already it's kind of hard to tell which is which is the long one and which is the short one. So it's a good way to sort of double check your work before you solder everything together. Also notice that there are, one of these pads is a square and one of them is a circle, and the square one is positive. They really, really want you to put LEDs in the proper way around. How often do you do the hackathons? Well, so the ones that I'm talking about were back in 2015, so it's been a long time. And it'll probably be, we actually found that they were very time intensive, and we've always been a small team, so like 15 people max. That was like our maximum. And so, believe it or not, with our wonderful dev team and everyone, so it really took a lot of our resources in order to do those hackathons. But it was really cool. We got, you know, intel, and I'm going to forget, I won't try and give an exhaustive list because I would definitely, you know, leave out some people and it would be embarrassing and insulting and whatever. But we had a ton of really cool companies on board. We did one of them at SparkFun in Boulder. We got a DeLorean. Our co-founder Adam bought a DeLorean on eBay for $30,000, and we brought it around the country and let people hack on it, which was really cool because the thing came with a beautiful, huge poster showing the electrical workings of the entire car, which is just, you're not going to see that now. It was along with a whole service manual as well, but that poster, man, if I ever get, I've thought about just like buying one just for the aesthetic of it. It's it's like 5 feet wide or something like that, and it just came with the car. Anyway, obviously that whole car was a style machine, and I can tell you that it worked much better as a style machine than a driving machine. It was not good. And even as someone who didn't really drive stick at the time, and I still don't really, but I do a little bit better, even people who did know how to drive stick, like, could only drive this one about half a mile before it conked out again. Like, we took it to repair shops across the country and got it fixed time and time again, but and we weren't even driving it from place to place. We were, flying, or somebody was driving it in a trailer or whatever. The thing is just not a good car. Good for traveling through space, not through time. So we have 2 things left. Our potentiometer, rheostat. It depends on sort of how you use it, actually. Voltage divider. But this one is called a variable resistor in this context. And I'm going to squeeze these together a little bit because they're just little claw grips that kind of grab the circuit board and hold it in place. And that way I'll easily be able to solder it. There we go. Get those through the hole. Boop. Haha. Squeezy, squeezy. It's a little loose, but it'll be fine. All right. Got these 3 on here. Anyway, I guess my point was, to answer your question, Tariq, we no longer really do hackathons. I went to a few that other companies were doing for a while, which was really cool. In the end, it ended up not being a good idea for us to run hackathons because it's so much work. But we got to meet a ton of cool people and, of course, help people build a bunch of really cool projects. I met a bunch of people in person that I'm still friends with. Some of my best friends, honestly. Oh, this doesn't even solder on there. It's just a clip. Cool. Were these ones soldered in? They were not. Okay. It's interesting to have the 2 of these next to each other to compare. Okay, so look, you even have a diagram of the little comparators inside there. That's so cool! So what I understand about this is that it's 4 comparators. Let's see, actually, what if we look up this chip? LM339N. I see quad differential differential comparator. Is it different? It is! Okay, cool. So it's got 4 differential comparators inside of there. I'm assuming that's how you pronounce that. I've always said it that way. It could be comparator or comparator. I don't know. it's probably a comparator. Okay, let's put this in here. Doing well on time. That's great. With chips, you'll find that they often come off the rail or out of this foam with their legs bent out at a slight angle, and that makes it hard to put them through your board. So what I do for that is I put it on desk, and then I carefully bend it a little bit, pressing it against the desk to sort of straighten those legs out. I don't want to do it too much right off the bat, because if you do it too much, then it's more of a pain to get out. Okay, so here we have a little notch in this side. See that there? And I have a little notch on my chip. That usually indicates that this is pin 1 over here at bottom left. And also it helps you orient the chip. Did not bend enough. Oh, there we go. Haha. Perfect. Friction fit. Beautiful. And these are spots for alligator clips, I assume. Okay, so you have in positive and in negative. Okay. And I'm still curious, she did say that you can use this, like everything you need to make it work should be in the kit. So I don't have anything prepared to put voltage into this bad boy. Although, I could actually, just a little battery or whatever. That could be interesting. Oh, I wonder if you could use it to test the remaining charge level in a battery. That'd be super cool. Although, I don't know. We'll see. Okay. One thing I really want to build is a jewel thief. Oh, yeah, so question. Comparator. Yeah, but see, that could be like comparator or whatever, here we have no socket for the DIL. No, there is no socket here. That's why I'm doing it last. So that, like, I'm not going to accidentally, expose it to lots of heat from soldering the other stuff on. And also B, it means that I've had all these other components to sort of get in the groove on, and I should be able to do this pretty quickly and easily without applying a ton of heat to the chip. There we go. You want to be pretty quick with these. Because of their sensitivity. It's one side done. Stop reflecting the light like that. Grrr. It refuses. There we are. There we go, and we have pin 1 labeled on there, which is very nice. All the pins are labeled, actually, which is especially nice. So you can really just continue to read this after the fact. The lead-free likes to do this, where it just kind of sticks. It seems to be a lot more sensitive to fluctuations in temperature than lead solder. So as soon as you remove the heat, or if it gets to a part that's more cool, then it definitely sort of wants to freeze up on you. Yeah, that looks pretty good. Didn't take too long. And now let's see what happens. Where'd my little battery go? Here we are. Assuming that I've put it together correctly. Oh, we have 4 LEDs. Brilliant. Okay. Interesting. I'm gonna turn down this super intense light here. So an interesting effect is happening here, where they seem to just stay on? Is that because I don't have a different voltage to compare to? Is it just comparing to itself? To be honest, I have very little idea of how this actually works. Okay, so they're all getting a little bit dimmer now. Oh, I have not read the entire page, so let's go take a look at that now. It's very pretty. Oh my goodness. I just want to use this as a nightlight, honestly. Like, imagine this sort of shining in the corner, and then you wake up and look at your little circuits. Do I have another voltage thing to compare it to, I wonder? It's +3 to +9 volts. I'm sure I've got a 9-volt battery around. Okay, so got this guy, and we were going to take a look at the website. Gonna unplug my soldering iron before I forget, because we seem to have a functioning circuit. And let's take a look at circuitclassics.com. Bargraph voltage indicator. Okay, so alcohol prep pad, bill of materials, required tools. You'll need soldering iron and solder. You may like a third hand for holding the board while you're working on it, or you can use a wooden stand to hold the board while you solder, like we just did. Batteries are not included in the kit, and you can choose to use the alligator clips to hook up a battery or power supply of your choosing, or you can assemble the SMT battery clip to the reverse side, in which case you'll want to supply either a 2032 3-volt coin cell battery or two 3-volt 2016s to form a 6-volt stack. Ah, brilliant. So a thing about how the batteries are named. Do I have my ruler here? There we go. Okay, before the show started, I decided to throw my ruler on the ground. So 2032s and 2016s. Notice how it says that you can use one 3-volt 2032 or two CR 2016s to form a 6-volt stack. They would be in series because it would be, positive, negative. The negative would be touching this positive, and then you'd be clipping on to the other negative. So, and the way that these are named is that they are 2032. 20 refers to 20 millimeters across. This is a wonderful little ruler from Evil Mad Scientist, by the way. I love it so much! Especially that they have markings on both sides so that you can really tell if it's like in the same spot on both. Ugh, it's so good. Anyway, so 2032, we've got 20 millimeters this way, and then 3.2 millimeters that way. And so if you have two 2016s, that's two 20 millimeters wide by 1.6 millimeters high. And if you have 1.6 plus 1.6 millimeters, you get 3.2 millimeters, which is the same as this, but twice as much voltage. But they won't last as long. So, battery terminology. Let's see. Assembly steps. Oh, they have how to solder beautifully. This is from Boldport, who makes beautiful, gorgeous circuit board art. So they give you a bunch of tips around, for example, how to align the chip and things like that. Oh yeah, they tell you to tack solder on pins 1 and 8, and that totally makes sense, actually. If I didn't have such a good friction fit, just from how I bent the legs on this, then that would make absolute sense to hold it in place. I would apply solder to pin 1 and pin 8 to sort of hold the whole thing in place. It would probably end up being a bit messy, and then I'd be able to do all the other ones and then go back and clean those two up or whatever. Testing. All 4 LEDs should be on when you power the circuit up, if you've built it correctly, as long as you are not using the white alligator clip on in plus to measure a voltage. Water time. You can test the circuit by using it to measure itself at one of the gold test points along the left-hand side of the board. The potentiometer knob adjusts the sensitivity of the circuit. Oh, of course, that's what it said at the start. That's what the whole cartoon was about. It adjusts the sensitivity. It's not turning the voltage up and down. Okay. Adjust the sensitivity of the circuit. For example, if you're measuring a voltage that is much lower than the battery or supply voltage that you're using, for example, remember, always measure a voltage that is less than what is powering this circuit. That's a good one. Okay, so it's very good that I was not going to measure this 9-volt with this, which obviously that makes sense. Duh, it's a comparator. So it wouldn't make sense, for example, to have a 3-volt in here and be like, oh, is this 9-volt more or less than 3 volts? Like that doesn't make sense. Okay, but if I power the circuit off of 9 volts, which it says plus 3 to plus 9 volts, I think that's the power. Also, so these are in minus and in plus. Which one is powering the circuit and which one is it measuring? This one is probably powering it. Yeah, and then you can also power it off of different supplies. So if I power it off of this, I should take this one out. Ground boy. And what I should do is have another little battery guy. So this is another CR2032 and a battery holder that has a couple of leads connected to it. And I'm going to do the same thing again. And I wonder where I put the test voltage in. It must be this. Look at how bright those LEDs are now. I'm going to assume we'll mess with that and see what is best. It's possible I will end up doing this wrong, in which case we will mess with it and maybe watch a video by Star or somebody about it. Okay, so this is the sensitivity. Right now, in ground, in positive, this should be showing lower, I think, but then again, I don't have a fully firm grasp on which thing gets plugged in where. So let's see. I'm going to go back to the source material. I have 2450 batteries in my SmartThings sensors. Oh yeah, and that's where you get 18650 batteries as well. They are, I believe they're, I've got one around here. I believe they are 18 millimeters wide by 65 long. Let's see. So this is an 18650 battery. That looks like about 18. Yep. And then 65. Yeah, it's a little longer, but it's got this little USB charger circuit on it. So the whole battery itself inside is probably about 65 long. So yeah, 18650s. These are really cool. They're from Tenergy, but I got it on McMaster. All right, so back to the project at hand. Use the white alligator tusk clip as a test lead to probe the test points along the left side of the circuit board. When you measure the test points on the Bargraph voltage indicator, you're using the tool to test its own internal reference voltages. That the circuit compares input voltage against. So it takes the voltage from whichever battery or power source you have connected to it, which is divided by the 4 resistors into steps of roughly 25% each of overall voltage. So each step would be about 1.5 volts. The instrument works by comparing the voltage on the input side to the voltage at those points. Okay, someone's actually using it here. Let's take a look. So they're doing what I was just doing in terms of how to power it, using a 9 volt into these points. And then they are, what? I need to look at this larger. So then they've got power and ground from the battery, also going to, okay. Oh, they made like a separate output from the battery that they're adjusting with the knob to go from 0 to 9 volts. Interesting. And okay, so there's a common ground, which makes sense, sort of built into this. And then they have the test point with that white cable going in. Okay. Oh, I haven't been showing you. It stopped my screen share. No. I had to look at the YouTube in large format to be able to see what was going on with their circuit there. Okay. Do not use anything greater than 9 volts to power the Bargraph voltage indicator. If you'd like to measure something, a AA battery should be about 1.4 volts and can be measured if you have a 3, 6, or 9 volt source. But if you'd like to measure something with a voltage above 3 volts, you must use either a 6 or 9 volt power supply for the Bargraph voltage indicator. So again, yeah, whatever you're putting in to power the board, whether it's this coin cell or a 9-volt or 6-volt power source through these, that needs to be greater than whatever you're trying to measure. All right, so yeah, I would have. I'm still not quite sure how we ended up with the result that we got before, but that's why this kit is great. You learn how to solder, and you learn a thing or two about how electronics does its thing as well. How do electronics? I mean, that's a whole big part of Forrest Mims's thing, and a big motivation, it seems, for Star, whom I'd love to get on the show someday. So, this is a little confusing for you, maybe, because I'm using this white. You know what? I have another ground one. We'll use ground and then white for the voltage. This is the this is the positive side, and then the negative side. Just gonna clip onto here directly. I think we need a common ground somehow. Oh, but you know what else we can do? We can connect the thing to its test points. What happens if I plug in here? And then touch this to there. Oh, look at that! So here, you're inputting at the input 1/4 of the total voltage. So here you have your voltage divided. Do it 50%, 75%, 100%. That's so cool! Oh, very exciting. Okay, so yeah, it's comparing this input voltage, which is coming from 25%, 50%, 75%. That is so cool. Oh, I love it. And let's see if we can get this 3-volt one working. So, may not be able to get it to work, but what I think is that it will work if I connect this in a common ground situation. So if I take this and connect it to there. It's not working. Actually, I sort of assume that that's what... Oh, wait. In negative. Should have been in positive, no? Oh, maybe that's what my deal was. Oh yeah, no result when I plug into the positive one. But the other weird... I wonder if the initial version was labeled backwards, because this confused me before as well. Here you have a little ground symbol, and here it says in plus, but it's connected to the little line with the ground symbol, which indicates that should be the negative, and that should be the positive. So maybe it's just labeled backwards. As with the capacitor before, it seems like there was an initial round that went out to the first set of backers, and my guess is that there were probably a couple of kinks that needed to get ironed out. But let's see. Here we go. So this was where it was working, right? The test points. Yes, good. Okay, so then I'm going to connect this other common ground guy to the ground of my little battery, and then the positive to the positive of my little battery. And do we have magic? We don't have magic! No magic. Huh. So I am doing an intentionally weird thing here by flipping around the positive and negative. Let's see what happens if we swap them around again. Probably nothing. Nothing, huh? Can I adjust the sensitivity somehow? Yeah. Also, it's positive that it's possible that this battery is dead as well. So that would not be great. What if I connect this guy? No, that way. Oh, something's happening. It might have just been a short though. Well, I'm really glad that we got the test guy working, like comparing the circuit to itself. Look at that! Look at it go! And I'll monkey around with this a little bit more. As with the previous one, I had to do a little bit of an update the next time, and so maybe we've got one more of these left. If you go to circuitclassics.com, there's one more, And you can find that if you go back. There you go. So the other one is the dual LED flasher, which is a classic circuit. A stable multi-vibrator. Is it? I think it is. I think this is a circuit that I know. Yeah, you got 2 capacitors, 2 transistors that are sort of being flipped and flopped based on those. It's not, I shouldn't use the word flip-flop because that's an actual thing. You got 4 resistors going to some diodes, 2 little LEDs, pardon me, and to ground. Yeah, this is a really classic circuit. Oh, I actually did, I'll show you next time when we solder this together. I did a little sketch that sort of turned this circuit diagram into a tree for Inktober one year. It's a really cool one. I think it's a beautiful circuit because it's got this balance to it, you know? Ground at the bottom, power at the top, or vice versa. You can, draw it whichever way. You've got 2 transistors, 2 caps. They sort of tie across each other. You got your 4 resistors and your 2 diodes. It's just a beautiful, beautiful circuit. And I'm excited to put that together. Cool. So for now, check out the Bargraph voltage indicator. You can get all of these on Crowd Supply for $40 each, $39 I should say. And all these lovely testimonials from excellent people. You can look up the chip itself, which I think is listed here. Yeah, LM393N, 393N integrated circuit. This might be, it's actually a 339, I think. But yeah. And our wonderful video from Boldport. Thank you for joining us for this live soldering session. They're some of my favorite sessions, honestly. I love putting stuff together, and I love chatting with you all while we do it, and we get to look at a bunch of cool stuff. I gotta pull these out again. Every time I talk about the Forest MEMS stuff, these are, in fact, some of the engineer's mini notebooks once these circuits came, and these are not by any means all of them. There were a bajillion of them. They were sold, this one, these 2 say Archer on them, which is well before my time. This one is from Radio Shack, which is now RIP. Although I think there are still some left somewhere or other. So yeah, you can still definitely get them on the internet and stuff. But there, you can see the graph paper that he was using here, and in some of them, the other ones, they're using like a notebook lined paper, which is why all of this stuff kind of has these notebooks lines on it, because that's how it was published in the first place. It's really all, I think it was hand lettered, which is incredible to me, and all hand drawn. So cool. So it's amazing that Star has brought these to life, and I hope that you have plenty of occasion to check these out in the future. You don't need to align the resistor stripes. You're probably trolling me because someone always says, is it you who always says that? I don't know. Anyway, sorry, artistic friends. This time I did not align them all correctly, like in the same direction. I try to do it when I think of it. It's not necessary. Troll. And we had fun looking at how batteries are described. That was super cool. And yeah, that's all we have for you tonight, folks. We'll see you tomorrow with something cool out of our mailbag. And otherwise, have a great whatever time it is for you. We'll see you soon, and hack on. Aren't these just so cool though? Like, look at it. I just want to have this going in the corner of my room like all the time. All right.